Hi there, good to see you all. I've been a long time coming to Mobile Warsaw way before pandemic, and I'm wondering, is there anybody else here who's been kind of joining Mobile Warsaw from way back, from like 2019, 18? A couple of faces, nice. So I obviously wasn't here 13 years ago, but like during my studies, I would attend Mobile Warsaw, and it's always been kind of my dream to present here, as this is kind of beyond the scope of what I normally do. I'm a Flutter developer, so I tend to stay within Flutter ecosystem, Flutter community. So it's super nice to be here around you all. And today I will try to talk about Flutter a bit more. Like back in 2019, 2018, Flutter was seen as some sort of novelty. Back then, it was mostly like if you were going with cross-platform, that would be React Native or Xamarin. And we can see that nowadays, Flutter is almost being kind of ignored as being like an old solution. There is so many cool stuff out there to pick from. So some of you probably know me, but let me just introduce myself. So I'm a Flutter developer. I work currently at this health startup called Visible, where we have where we build a platform for chronic illness. We have a wearable Bluetooth armband that you wear on your arm, and this is a HR and sleep tracker. And this is meant to help people with chronic illnesses like long COVID, to help them pace, help them go through their day. I'm also Flutter GDE. This is a title by Google that is granted to some community members that tends to go and do talks about Flutter and other Google technologies. And if you want to follow me a bit online, you can find me on my website, and you can sign up to my newsletter where I sometimes share some stuff about Flutter. So if you enjoyed today, I kindly invite you to follow me online. So as Piotrek mentioned, last month we had a talk about Flutter in general. It was comparing, Gabriel was comparing that to Kotlin multi-platform. And that was like a more high level. And today, I think we're going to go a bit deeper just to see what is I think, especially if you're an iOS or Android developer, it might be interesting to kind of see and understand how Flutter ties to the native APIs. This has been a topic way back from like 2018, Flutter 1.0, that kind of, it's not that easy to work with the native APIs. Like if you want to use Bluetooth, if you want to use share extensions or something like that, you better go with native. But I would argue that I think there's a certain power in Flutter in the fact how it's been built. So for instance, in Flutter, you have your native projects available to you. You can open them in Android Studio, in Xcode, and just work with them. As opposed, for instance, to Xamarin, which was a sort of magical package that was hiding the internals from you. A similar thing was happening to React Native. Now it's much more convenient to work with the native project. But if you work with Expo, right, you don't really have the native project to you. So it's been like, in my view, the fact that Flutter is just built on top of the native platform has been a very powerful thing. And this applies also to the plugins. So, or like the native interoperability. You can access almost any native API, whether it's just showing a notification or getting the permissions or accessing even like a user defaults or anything like that. Not only, like you can also get the informations like receive intents, you can receive remote notifications, also all that stuff without really kind of building any sort of abstraction. But at the same time, throughout the years, the architecture of plugins or being able to invoke this native functionality has been changing. And comparing to some modern solutions, I would say the state of the art in Flutter is no longer that pretty, no longer that compelling. So today I'm going to talk about some of the history, some of the ways you could access the native APIs. And at the end, I'm going to show you something cool and do a little bit of a demo just to show you and maybe excite you. If you have never tried it before, it may be a bit more compelling to try Flutter right now. So in Dart and in Flutter, almost any library, anything is a package. So you can have a package that is Dart only, but you can also have a package that has some native code. And we call them plugins. There's several different ways to build a plugin. And the most common, the one that you will learn on the first page of the documentation, is going to be method channels and event channels. This is essentially message passing between Dart and native platform. This can be encoded in many different ways, but it means you have some message, you send it to the native side, it's getting interpreted, you can invoke some function based off of that, and you send the result back. And it can go both ways, and that's fairly simple and also quite powerful because you don't really have to understand much. Like, it's very simple to understand. You can trace the invocation from the moment you call the function in Dart to the moment when you receive it in Kotlin or Swift. After that, there's been some, so with method channels and event channels, and you're going to see this in a second, it's quite annoying because you have to essentially write them by hand. So you write your JSON strings, you pass them between Flutter and Dart. So obviously, Flutter team wanted to improve this a little bit, so they introduced more type-safe, more professional ways to send data or invoke functions between Flutter and native. One of them being pigeon. That's a funny name for the library, but that's essentially like a messenger kind of thing. I think that's hence the name. And also, I've seen people using protobufs and flat buffers, and essentially you can kind of encode your data between Flutter and native in any way you like. You can even just send ones and zeros if you like. And a couple of years ago, there was this new development in Dart. This has been known in many languages, in many environments for years, which is called foreign function interface. This allows you to invoke any C function from a C library. And by the fact that Obj-c, and we also learned that a month ago, Obj-c is compatible with C, you can essentially invoke Obj-c functions. And through the compatibility layer between Obj-c and Swift, you get to call also the Swift functions. So through this sandwich or through this path, you can essentially invoke directly from Dart a Swift function. And obviously, you wouldn't like to do this manually, so there's also a code generator for that. So that's kind of the current spectrum, and there's also one other cool thing happening right now, which will, like, for me, is very exciting. This is something that I spent long hours overnight just to try, explore, and show it today. So method channels and event channels. So as mentioned, this is message passing, and typically the basic codec, or like the basic form that you send the data, which is essentially a function name and arguments, would be a JSON. So this is error prone and also not super performant if you think about it. In reality, like, there is nothing like you can send any sort of data as long as it's like not, I would say, extremely huge, and you will not notice any hiccups. But obviously, if you like, you can encode this data in a much more efficient form by having a different codec. Like, you can have your own optimized, compressed representation of your data that you send. Like, for instance, if you'd send a lot of image data, like a lot of binary data, you wouldn't obviously send this as a base 64 encoded image, right? You would probably try to share the data directly without copying, for instance. As mentioned, this is easy to pick up, but with bigger projects, it tends to become messy, and especially if you have a team of multiple developers, you want to have a way to define some interfaces, some contracts. And one quite annoying disadvantage is that it's always async. So because this is a message passing between platform and a native project, there is a hop. You need to await for the result. Even if it takes 1 nanosecond, you have to await this result. And this gets sent to the message queue, and then you receive the response as soon as it's available. Example you can see here. So at the top, you just see the Dart definition of a method channel. You have to provide it with a name, and then you can invoke any method. The type conversion is pretty straightforward. If a type is supported on both sides, it's going to be mapped like double to float, things like that. So everything is going to be nicely converted, but obviously you don't have the type safety. So like, you can provide an int, but if the native implementation returns a string, it will just fail. On the native side, here we have an Android example. You just get kind of a callback that tells you this function has been invoked, and you can do this both ways. And An augmentation of that would be event channel, which is essentially emitting values, for instance, from the accelerometer. So for instance, this is a sample of an accelerometer that works on method channels, and this can send the data about the accelerometer from your device as soon as it's available. We need to autoplay this, sorry. And it's essentially as fast as your UI, as fast as your device. There is no latency involved, and it works just fine. And majority of the plugins that you'd find will use method channels and event channels. Next up, Pigeon, protobufs, and flat buffers. I've seen them all in different projects. Pigeon right now is at version, I think, 25. So there has been a lot of breaking changes. So it took them some time to kind of end up with a more or less stable API. And this is one of the reasons why I don't really enjoy working with that. But at the same time, a lot of the, I would say, first-party plugins, the ones from the Flutter team or from Firebase team, because they're quite chunky, quite complex, they would use that. They allow you to have a very nice type-safe API. So you define your contract, and then from this contract, your code for Dart, Kotlin, Java, Swift, Objective-C is generated. And this way, you don't really have to manually type like a glue code between your Flutter and native implementation, which is very convenient, especially if you have a bit bigger, a bit more complex models to send back and forth. One thing that was always annoying to me in Flutter was that in other frameworks, in other technologies, it wasn't really that difficult to have access to the native platform. So for instance, recently even in Compose multi-platform, there was an experiment to just have access to the Swift UI views as composables, which is kind of, if you don't really want to deal with that, it's very convenient. Also, with Kotlin multi-platform, you get access to the Swift APIs directly. You don't have to do the message passing. Obviously, there are some limitations, and someone needs to provide these libraries, this namespaces, and so on. But if you want, you can essentially have an as-user defaults in Kotlin as if this was a Swift code. And for me, this is very compelling. For instance, this is another example where you can access just a normal Swift API in Kotlin. Here you just have access to the mkdir, you have access to NS file manager, and so on and so forth. So it's very convenient. And back in the day, in Xamarin times, it was possible. I mean, for me personally, I actually learned iOS and Android APIs from C# because I was writing Xamarin apps at the very beginning. And back then, you would write your activities, you would write your view controllers, you would write your UI view animations in C#. And this was mapping from Java or from Objective-C back to C#. And just before the presentation, there was this discussion about different frameworks, and someone said that these languages are very, very similar. Like, there is not much difference between Java and Objective-C. And obviously, there are differences. But in essence, you are able to represent the same ideas, the same concepts in all of these languages. And that was a cool experiment. It lasted for many years. It's like Xamarin is already kind of dying. There is another tool called Maui, but I don't think it has that much traction. But it was a very nice way to be able to access native APIs without having to deal with the entirety of the native project. The same would happen to the iOS. You would have access to the iOS APIs, and I remember myself writing the UI kit animations in C#. So the big question here is, can we finally have the same experience in Dart? And I'm not saying we shouldn't write any native code. Like, in many cases, sure, extensions, we have home screen widgets, we have foreground service in our app, we have background tasks on iOS, we have remote notifications, and so on and so forth. Like, in a lot of these cases, you would prefer to write your code in Kotlin, in Java, in Swift, or anything else, because this will be just more convenient. There is no point in having an abstraction in Dart just for the sake of the abstraction. And oftentimes, these APIs will be so different or not accessible on the second platform. Like, I don't see a way to have an abstraction over a home screen widget between iOS and Android. These are two very different ways to write widgets and 2 different ways to refresh them and so on. So these parts would be written by you separately. But where you are generating the data for these widgets, that could be really nicely abstracted away. So can we have it in Flutter? And the answer obviously is yes. And there is this new cool tool right now that's available in beta. It's been in development for the last, I think, 2 years, and it's getting to a point where you can essentially use it in production, which we are doing. We are using this in production with a couple of libraries that we have. So we still have a bunch of code that's been written with method channels and kind of the old-fashioned way of having access to the native code. But with J and iGen, we have a really cool stuff going on. And this will be a time for a demo. So let's praise to the gods of demo for us for everything to work. We will switch between different IDEs and emulators and such, so this will be a bit hectic, but I hope it will all be clear at the end. So I'm going to switch first to the Android Studio and show you my emulator here. So I have this simple app here that's a Flutter app, but it has a PDF viewer. And sorry, I need to disable the breakpoint. Yeah, that's what I thought. We have this quite simple app that just shows PDF preview. And when you're building something like that, you don't want to build a native app just for the PDF preview if everything else is in Flutter, like your authentication or anything like that. So we have a plugin that works and displays the PDF. And I built this way back using method channels. And for the sake of experiment and fun, I want to try out this here. I'm going to make the font size a little bit bigger. So here we have this PDF view controller. I hope that this is all legible to you all in the back. If not, please come closer. So this is very simple. Essentially, what we have here is that we have this static field on this class, and the static field exposes some methods. Very simple, set page, get current page. But you can notice that this is like not actually used anywhere here in this code, so I have to use the keep annotation and make sure that the progress rules are correct. But if we go here, we have our view implementation. So this is essentially an Android view. This is wrapped with a platform view so that we can display this in Flutter. But what we have here is just a PDF view from this library from Bartek ASC PDF viewer. That's one of the nicest open source PDF viewer libraries for Android. And we just define our view in Android, in this particular case in Java, but this could be easily Kotlin code. And we just define our view. And here what we do is that we have our callbacks. So anytime a page changes or when the PDF gets rendered, we just invoke this interface here. And if we have a look at another class here, I have another interface that's called PDF status listener. So this is just an interface unloaded on page change on error on this post, and we will use that for sending the data back to Flutter. So this is very basic Android code. Now let's go back to our Dart code. What happens here is that we have our view, nothing fancy, PDF viewer page. In this page, we have a couple of fields. We have our PDF data, so this is all bytes. So we're not accessing the file, we're just reading this from the file. And here, a cool thing happens, and this is super exciting to me. Essentially, I'm instantiating a Java class in Dart. And the first time I used that, it blew my mind, but at the same time, I reminded myself of the Xamarin Times or other ways to kind of instantiate a native class. But here, this is essentially our native class, our Java class. And I'm going to show you in a second how it's been built, but just to show you in reality that this is actually the same class. If I go to my PDF view controller, and if I go here to this method, and I attach my debugger to the running application. So right now, I'm debugging this both from VS Code as a Flutter application and from Android Studio as an Android application. If I switch back to my emulator, set a breakpoint here, and open any page, you can see that I hit the breakpoint here, and it says that the PDF view controller has an address of D5F7, and so on and so forth. I will just carry on with that. And here I hit this breakpoint. And if I would now type this to string, this also has d5f address. So this is essentially the same instance of the same class, which is super cool. So this tool allows you to create something called binding to a class, to a library, and you can instantiate this class from Dart. And there is a bit of proxying code going on so that you tell, like, this tool is able to instantiate a given class on the native side and gives you back the pointer to this class and deals with things like memory management. So for instance, if this goes out of scope and the garbage collector either on the Dart or Java side kicks in, it will also clear the reference on the other side. So there's a bit of synchronization going on, which is for our convenience. You don't have to deal with the memory. Obviously, you can bypass this and make sure that you deal with the memory, but I think nowadays you would rather avoid manual memory management if you don't need to. And if we navigate through the pages, we get the updates here that we are on the page 1 out of 71 and so on and so forth. And if we would put the breakpoint here on the on page change listened, on page changed, we would see that this changes. So if I swipe here, I can see that let me increase the font size in my terminal. It doesn't change. Never mind. It's a debug console, not terminal. So we can see that the page changes. And what is super cool about this is that I have my PDF status listener. So if you remember from the Android side, this was just an interface. It had no implementation. And the implementation that I provide comes from Dart. And this is super cool because if I have some shared logic, I can just implement it here and then send it to Java. And what is you will learn in a second, you can also send it to Obj-c. And by having this sort of wrapper API, you can build your logic on the Dart side, or vice versa. You can build the logic on the native side and have a nice, convenient API. The nicest thing about it is that you don't really have to deal with the method channels. You don't have to deal with the message passing. You don't have to deal with the flaky code generation for your contracts. If you have a class on the native side and you define it in your configuration file, which is here, for instance, I just define this like that, it will generate bindings to that. The bindings are messy, like you don't really want to read them, but if you want, you can. This is like a generated code. It's a lot, like it will be thousands of lines for a couple of classes. But on the surface, it's very convenient, very nice to work with. And we can pass, for instance, here this instance. All right, so this was a very simple demo, but obviously you can build much more cooler stuff with that. So for instance, there's this very common API on Android that allows you to update your app when the new version is available in the Google Store, in the Google Play. And there's a couple of plugins, community-driven, but in reality, the API surface area of this library is super simple. There's essentially 2 functions and a couple of callbacks. So building entire plugin and method channel interface for that, it doesn't really make that much sense. And also, for fun, it would be cool to just be able to access that. So one thing that I tried, and you can see this in my repo as well, is the bindings to the Google Play app update library. And what I hope this will tie to a bigger effort. Essentially, last year, Flutter team announced that they will be building a set of different libraries to be able to access these native APIs, like for instance, native Android, like core Android APIs or core Google Play APIs, without actually having to go through generating the bindings yourself. There would be packages available on pub.dev, which is the repository for packages, that you could just access the same way as you can access Swift APIs from Kotlin. You should be able to access your UI notification center or anything like that from Dart. And I hope that this will be like one of the bricks to make that happen. What about the iOS side? So with Objective-C and Swift, the progress on code generation or binding generation is a little bit less advanced. So in this particular case, currently the only the only stable way would be to generate the bindings to Objective-C. So Swift is very experimental. You can generate bindings to Swift, but in reality, you would rather have this generated for Objective-C. So you would go for this compatibility layer anyways. So for instance, I have another small demo here. Let me just quickly find it here. So I have generated bindings using a tool called FFI-Gen to Foundation framework on macOS in this particular case. But you could obviously generate this for iOS or anything like that. Actually, Foundation is kind of cross-platform, like it's the same on iOS and macOS. So it doesn't really make that much of a difference. And here I'm just trying to access NS user defaults. And I was playing with that for a while. Like for instance, I tried to access the health kit, I tried to access metric kit, and so on and so forth. And it somewhat works. Obviously, the simpler the API, the easier to access. And if you are an iOS developer, you probably also would prefer to access the Swift API of a given framework rather than the Objective-C. Currently, you have to go through the Objective-C APIs. But for instance, here I just define my classes, my namespaces that I want to have access to, and provide access to the library, run some code generation code for a second, and then I'm able to just get access to for instance, in this particular case, to the NS user defaults. So for instance, if I would just call defaults write, what do you want me to write in my defaults? 3, 2, 1, somebody. 96, let's write 96. Right, so now if I just try to run this, sorry for the name of the files, play audio, because before it was playing audio. And I can see that this is actually exposed. So I get access to the NS user defaults directly from Dart, as opposed to going through the method channel, writing Swift or Objective code, and then returning back this answer. That's not going to work for everyone, but for instance, at our company, we have this big library that we use for the heart rate camera reading. So you put your finger to the camera, and then it just tells you what's your heart rate and something called HRV. And we have a vendor for that. We haven't built this ourselves. But they have exposed a framework, a dynamic framework, where like we only have access to Oblivion framework, and we don't really have access to the source code. So we're considering whether we are going with the traditional way of having a method channel, but in the end, we just decided, let's try generating the bindings directly. And what happened is what was like, obviously it took a bit more time initially than just writing this code manually and passing the JSONs back and forth. But in the end, we came up with a really nice API across Android and iOS. The vendor has a really nice, consistent API as well for the libraries. So we were able to, for instance, get access, like create an instance of this class, have this as have this delegate, and get access to all the callbacks. So we get all the callbacks, and we can just pass them outside of this class, and we can get responses from that. And this required kind of no native code from us. We just pointed the classes and frameworks that we want to generate bindings for. Just a couple of classes here, a couple of enums, stuff like that. And in the end, we had this really convenient API. So it works, and it operates on thousands of users right now. So this is extremely satisfactory. Cool. So wrapping up, I have shown a couple of cool tools, JNI-Gen, FFI-Gen, that allow us to generate the bindings to the native libraries without having to write the native code itself. Obviously, it's not going to work always. Sometimes you just have to write the native code. For instance, you want to have a foreground service. You want to receive have a broadcast receiver on Android, or maybe like you have a share extension, home screen widget, things like that. But for instance, in our case, where we have a third-party library, or when we only want to access some core system APIs, it becomes very convenient to be able to just type NS user defaults dot something or UI application delegate. Stuff like that is possible. It's not widely known just yet. It's still experimental, but I think this is why meetups are what meetups are for, to just show stuff that's on the cutting edge. Hopefully, this will all come to the stable version in the next couple of months, at least for the Android part. The Swift code generation seems to be a bit trickier. There is not much effort, but at the same time, once that's in, I think there will be like a parity in user experience, in dev experience, at least between in terms of accessing the native APIs. That will be all from me today. If you want to learn more about that, I have prepared some resources on my website. So if you go to the roszkowski.dev/plugins, you will find a couple of links and also the slides and a link to the repository. The JNI Gen is good to use in my opinion. And also if you want to kind of understand things that are way beyond my understanding, there's an amazing talk from the Dart team engineers that worked on that. And they just explain exactly step by step how these things work on the levels that we normally don't have to deal with as just mobile app developers. That will be all from my side. Thank you so much for attention, and I hope you have some questions. Thanks.
Dominik, thank you very much for amazing presentation. Do we have any questions? Oh yeah, the first one.
Is this one working? Okay, nice. No. I would like to ask, like, what are the performance implications of using this type of interoperability? Does it usually come with like a major performance downside, or what does it look like?
That's a really good question. So when it comes to benchmarking the performance, I didn't have a chance to kind of make it kind of sweat. But at the same time, like in our case, when we get this camera reading and we pass the data through the Obj-c Java bindings, we are sending the data at the resolution of, I would say 90 hertz, 100 hertz, and it just doesn't have any sort of impact, and it just works. Obviously, this is just a number data. It's not a image texture or anything like that. So probably if this would be a bigger package, you would probably try to avoid, for instance, copying the data between. What is, I think, happening here is that this is not actually copying data. We received like the pointer to an object on the Java side, but later on when we operate on that, we do a bunch of copying and creating new lists and so on in Dart, so it becomes a performance more like a issue on the Dart side rather than on the Java side. I don't think there will be any significant performance issues, if only this would be faster than method channels because you don't have to decode and encode the data.
Thanks. So I wanted to ask, can you use native views in Flutter, like let's say calling a map view or some other native view?
Yes, you can. So for instance, the demo that I've shown about the PDF viewer, that was Android surface that was just displayed in Flutter. So you can display views, not native views in Flutter any way you want. You can transform them, you can put them between layers, you can make them in scrollables and so on and so forth. Obviously, there is always asterisks that like this may have some performance implications. If you want to have high performance, you have to use a different type of platform view than if you want to use kind of high fidelity where you have a nice gesture handling and so on and accessibility. And on iOS, this is so much simpler. Like because of the hardware unification on iOS, this kind of has been working very well since the very beginning. There is one thing that you have to be aware that on the older versions of Flutter, because there is this hop between Flutter and the native, the gesture that you pass, there might be a 1 frame latency. So obviously, if you have 60 hertz display, you may notice the latency. However, with the 329, which is the current stable, there was this effort to make the platform threads merge so that this event of gesture passing through from Flutter to the native view will be synchronous, not asynchronous as it used to be. So this has been resolved. I mean, I don't think they have already made a change to this particular issue of 1 frame latency, but that has been kind of solved right now. I think it's a matter of implementing a proper gesture handling right now. So you can show. There are some caveats. So for instance, if you have a very expensive view, you may want to just open a new view controller or a new activity or a new fragment. But in most of the cases, like in our case, when we have a camera preview, when we have, what else can we have? A video player or web view, stuff like that. These are all platform views that are getting displayed in Flutter. You don't really notice any performance issues or anything like that or glitches. And you can do, like this is essentially a widget in Flutter. So if you want to have it in a list view, you can, and it typically just works.
Okay, thanks.